This video will cover the Year 9 Maths Applied Simultaneous Equations test preview. I'll put the time tags down the bottom for the question numbers and the question types if you'd like to use those to skip to the question that you want some help with. I'll go through the simultaneous practice quiz here. To be honest, I think I'd do all of these questions except for this one here using elimination. I wouldn't use substitution because this is the only question where X is the subject or is out the front by itself. But just to mix it up a little bit, what I'll do is I'll do some of these questions in a few different ways just to give you a bit of an idea of different ways that you approach these sorts of questions, and maybe one way will make more sense to you to see how we go. So we'll kick off with question 1, and in this one I'll do this one as elimination. I'll call them equation 1 and equation 2, and I'm having a look at eliminating the x's here. They're both positive, so I'm going to do equation 1 minus equation 2. That means that x minus x makes nothing and eliminates it, and y minus minus y makes 2 y's, because 2 negatives make a positive. And I've got 15 minus 3, which makes 12. Balance method says to times by 2, so I'll divide by 2 both sides, and x will be 6. Bring this equation up here, so I've got a little bit more room. I'm now going to sub y equals 6 into, and because it's elimination method, I can go into either equation, so I'm just going to go into equation 1 because it's all positive. So as I write out equation 1, every time I see a y, I'll just replace it with a 6. So x plus y is 15. Back to balance method, take 6 from both sides, and x will be 9. I'm quite lazy in the way that I answer these, so I would put this as a coordinate answer, an xy coordinate, so it will read 9, 6, like this, and this would be my final answer. Some people prefer to say x is 9 and y is 6. For the purpose of the video, I'll just stick to coordinates from here on in. The second example here, I would do this by elimination just like I did in the first one, but just for the sake of showing you an alternative way of doing it, what I might do is rearrange the first equation so that it is, if I take y off both sides, this equation would become x equals minus y, and now we'll use substitution just to mix it up a bit. So we'll call them equation 1 and 2. I'll say I'm going to sub equation 1 into equation 2. Making this note just helps you later, and it also helps your marker to know what you're doing. So now what I'm going to do is I'm going to write out equation 2, but every time I see an x, I'm going to make it a minus y. So it'll be minus y equals 2. That means that minus 2y equals 2. Balance method, let's divide by minus 2 on both sides. Oh, making a mess of that. Try that again. Let's divide by minus 2 on both sides, and I'll be left with y equals minus 1. Now I'll sub that into, now this bit's important. You've made this note over here for yourself specifically so that you remember when you get to this bit here that you are going to go into the opposite equation. So here we're going to go into equation 1 instead. Okay, so now we'll write out equation 1, but every time we see a y, we'll make it a minus 1. So x minus 1 equals nothing. Back to balance method. Add 1 to both sides, and x is 1. So my answer is, when x is 1, y is minus 1. And that's my final answer. Next question. Let's go for straight elimination here. The reason I'm choosing elimination is that I can see that there are y terms here. There's negative 1y's and there's positive 1y's, which is perfect. So I will call them equation 1 and equation 2. At this time, 1 is negative and 1 is positive, so I'm going to add equations 1 and 2. And that way they'll eliminate each other. If I subtracted them, I'd end up with negative 2y's, and I don't want that. So here we go. 2x plus 4x makes 6x's. Negative y plus y, working down the column like this, makes nothing and eliminates. And 3 plus 3 makes 6. Switch to balance method. Divide by 6 on both sides. And x will be 1. Let's take this up so we've got a bit more room. I'm going to sub into, and I can go into whichever one I want because it's elimination. So I'm going to go into 1 because the numbers are smaller. Makes it a bit easier to work with. And every time I see an x, I'm going to replace it with a 1. So now I've got 2 minus y is 3. Switch to balance method, and I'll take 2 from both sides. All I'm left with is negative y, and over here I've got 1. Switch those negatives. Technically what I'm actually doing here is dividing by minus 1 on both sides. We don't normally bother showing that though. And y is minus 1. So I've got the answer when x is 1, y is minus 1. Same as the one above. Just by coincidence, by the way. Alrighty, now question 4 is the one I was talking about right at the start of the video. X is the subject of this equation. So if I wanted to do elimination, I'd have to rearrange that equation. So it's easier just to go for substitution. So here I'm going to sub 2 into 1. And as I write out question 1, every time I see an x, so 2 times x, it will be replaced with 8 minus 2y. So there's a bit of expansion to do in this one. So 2 times 8 is 16, 2 times negative 2y is minus 4y. Oops, minus 3y equals 2. I'm going to collect my like terms. Balance method. Let's take 16 from both sides. And minus 7y will be minus 14. Let's divide by negative 7 on both sides. And y will be 2. Now that we know that, we're going to sub into, now this is substitution, so it matters. Look back at the notes you made yourself. If you went into 1 the first time, you have to go into 2 the second time. So as we write out equation 2, every time we see a y, we will replace it with a 2. So this one, x is 8 minus 4. So x is 4. My final answer is when x is 4, y is 2. Question 5. Let's do question 5 by elimination. What we'll do though is we'll manipulate the equation a little. So let's take the second equation and make the x's match. You can make the y's match if you want, but I'm just going to multiply the whole equation by 2 to make everything 2 times bigger. So this equation will become 2x minus 2y equals 4. And now this will become equation 1, and this will become equation 2. And 2x and 2x are both positive, so this time I'm going to do equation 1 minus equation 2 so that they eliminate one another. 2x, I'll scribble this out so it's not in the way. 2x minus 2x makes nothing. minus 3y minus 2y makes minus 1y. Okay, so it's minus 3 plus 2y in other words. And then 0 minus 4 makes minus 4. So that means that y is 4. And the reason for that is that I've divided by -1 on both sides. Now that I know this, I'm using elimination, so I can go into whichever equation I want. I think this time I'll go into equation 1, so sub into equation number 1. Every time I see a y, I'll replace it with a 4, so I'll have 2x's minus 3 times 4 equals nothing. So 2x's minus 12 is nothing. So if I say balance method, add 12 to both sides, 2x's will be 12, divide by 2 both sides, and x will be 6. So my answer is, when x is 6, y is 4. That's my final answer. Question 6. In order to do this, I'm going to have to make my y terms match, or that's going to be the easiest way that I can see. So let's make everything on this side 4 times larger. So what I'll end up with is 20x's minus 4y's being equal to 52. I'll name them equation 1 and equation 2. And if I have a look at 4y and minus 4y, we'll cross this one out so it doesn't get confusing in the mix. They're the opposite symbol, so this time we're going to add equations 1 and 2. As we work that out, 2x plus 20x makes 22x's. 4y plus minus 4y eliminates, and minus 8 plus 52 makes positive 44. Switch to the balance method. We'll divide by 22 on both sides, and we'll find that x is equal to 2. Let's take that over here where there's a little bit more room, and we will sub x equals 2 into whichever equation we want. Let's go for equation 1 because it's a bit smaller. It'll be a bit easier to deal with. So we'll say every time we see an x, we'll replace it with a 2. So this one will become 2 times 2 plus 4y equals minus 8, which means that 4 plus 4y equals minus 8. Balance method, we'll take 4 from both sides, and 4y will equal minus 12. We'll divide by -4 on both, we'll divide by positive 4 on both sides. And y will be minus 3. And we've solved that one. So our final answer is, when x is 2, y is minus 3. Question 7. This one would just be answered if we just use elimination. What we might do is we'll double the second equation and make a new equation that reads 10x minus 2y equals minus 54. I'll call it equation 1 and equation 2. Because we're matching the y's and they're different, let's add these two equations together. So we'll find that 3x plus 10x makes 13x's. 2y plus minus 2y eliminates, and minus 11 minus 54 will make minus 65. Balance method, divide by 13 both sides, all I have left is x, and over here I have minus 5. Need to sub this in, so let's sub into equation 1 because it's got smaller numbers and we can go into whichever one we want. So every time we see an x, we'll replace it with a minus 5, so it'll just read 3 times minus 5 plus 2y equals minus 11. So we've got minus 15 plus 2y equals minus 11. Let's balance method, so we will add 15 to both sides. We'll find that we've got 2y, and that will equal 4. Let's divide by 2 both sides, and we'll be left with y is 2. So our final answer is, when x is minus 5, y is 2. Question 8. Let's try something a bit different with this question just to mix it up a bit. This time what I might do is some pretty big numbers here, and I don't have a calculator. Normally I think I'd probably just multiply this by, multiply this by 9 and do it with a calculator, but I don't have that luxury. So what I might do is I might divide this equation by 3, and I might multiply this equation by 3, and I'm aiming to make my y's a pair. So that will make this equation 3x, that will make this equation 2x plus 3y equals 1, and that'll make this equation here 15x minus 3y equals 135. I'll call them equation 1 and equation 2. And because my 3y's have got different signs, I'm going to add these equations. So I'm going to do equation 1 plus equation number 2. And now when we expand these guys out, or when we work these ones out down the row like we have been doing, we'll say 2x plus 15x makes 17x's, 3y minus 3y eliminates, and 1 plus 135 makes 136. So now if I switch to balance method, and I divide by 17 on both sides, I will get that x equals 8. And now I'll just sub that. So if I grab my orange, I'll just bring that up here. I've got a bit more room, and I'm going to sub into whichever equation I want. So I might go into 1. Numbers are a bit smaller in that one, and that will mean that 2 times x plus 3y equals 1. So 2 8's 16. Switch to the balance method. I will subtract 16 from both sides. I'll be left with 3y equals minus 15. Divide by 3 both sides, and y will be negative 5. So my final answer is, when x is 8, y is minus 5. Last couple of questions. These ones have got fractions in them, decimals in the first case, but either case, I don't want to deal with those. You can if you want to, but I find that it's probably less of a headache just to get rid of them altogether. So what I'm going to do is I might manipulate the first equation by making it 8 times bigger, and I'll manipulate the second equation by making that one 6 times bigger. Now you can do whatever you like with this, but in this case what I'm aiming to do is make the x's match. So I want to make them both 12x. So that's going to change this equation here to 12x plus 40y equals 128, and it's going to make this equation here 12x rather minus 3y equals 42. Now my x's match, they're both positive, so if I make this equation 1 and this equation 2, I'm going to add my two equations together to eliminate. Sorry, I'm going to subtract them, aren't I? I'm going to subtract my two equations because they match. And what I'll be left with is 12x minus 12x eliminates. 40 minus 3y makes 43 groups of y on this side, and 128 minus 42 leaves me with 86. I switch to balance method and I divide by 43 on both sides. I'll end up with y equaling 2. If I take that answer, bring it up here where I've got a little bit more room, and I sub into equation 2. Every time I see a y, I'll replace it with a 2. So what I'll end up with is I'll end up with 12x's, excuse the music, minus 3 times 2, which is 42. So I've now got 12x minus 6 equaling 42. Switch to the balance method and I'll add 6 to both sides. 12x is now equal to 48. Last move, divide by 12 both sides, and x is 4. So my final answer is when x is 4, y is 2. Move on to question 10. Question 10's got some really ugly fractions in it, so we need to get rid of those. You can work with fractions if you want, but personally I'd try to get rid of them. So what I might do is I might multiply this equation by 6, and I might multiply this equation by 4. And so that's going to change these two equations. It's going to make the first one read 3x plus 2y equals 12, and it's going to make the second equation read 12y minus x equal 148. Now you might notice that those two equations still don't match, so we might triple this one so the x's match, and that will make this one read, and I'll just rearrange it a little bit as I go, minus 3x's. This is just so the x's are under the x's, plus 36y equals 444. So this one's redundant. Let's call this one 1 and let's call this one 2. I've got a plus 3x and a minus 3x, so let's add these equations. So I've got 1 plus 2 here, and let's see what we get. 3x minus 3x eliminates. 2y plus 36y makes 38 y's altogether. That will equal 456. And then if we divide by 38 on both sides, that should make y 12. Now that we know what y is, just give ourselves a bit more room over here. We will sub that. Let's go into equation 1 because it's got much smaller numbers and it's a bit friendlier to work with. So let's rewrite equation 1, 3x plus 2 times y makes 12. That means that 3x plus 24 will make 12. Balance method, we'll take 24 from both sides. So I'll end up with 3x's equaling negative 12. Back to balance method. Divide by 3 both sides. And x will be minus 4. So my final answer is when x is minus 4, y is 12.